record. There we go. All right, well, we are into our last two topics this week in this combination of chapters 2 and 3, solving equations, and then using applications where we have to solve equations. I actually blocked out like 2 days for each of these sections, today and tomorrow dealing with percent type problems, and Wednesday, Thursday with back to our geometry formulas that we worked with in part of chapter 1. But it's not just to be quite plugging numbers in. One of the numbers in the middle will be missing. So you'll kind of have to rearrange and solve that formula, the geometry formula to find the missing side length or something like that, or missing angle. And then a new thing, maybe for all of you, for some of you, called the Pythagorean theorem. How do we use this special formula to find the sides in a triangle? So anyway, that's this week, just these 2 sections, but maybe like, yeah, giving you plenty of time for that. So percentages. All right, we deal with percentages a lot in our everyday life. I bet most of us kind of have a good general concept of what a percentage is. In general, we kind of say it's a number that represents how many parts out of 100. So whatever situation or value we're talking about, we divide it up into 100 pieces, and we say we've got 25 out of 100 is 25%, or we have 60 out of 100, or that thing is on sale, 10% off. What would be 1/10 of that price that we're removing? So they take the shape of some kind of equation. We're going to find the missing value. And most of them, really, we don't emphasize this technique, but if you think it looks like it makes sense to you, I like to just present it, but then we kind of move on again to sort of this translation model that works for lots of folks. But if I say I have a fraction 4/5, I have this much of a whole, I have 4/5. Well, we're asking ourselves, how many parts out of 100 is 4/5? Basically coming up with like an equivalent fraction. How could I turn 4/5 into something over 100? And if you think about it a little bit, we could do our solving techniques here. I could multiply both sides by 100 to figure out what our value is here. I might cancel out the 5s and get, 4 times 20 is 80. So as a percent, 4/5 is 80%. 80 parts out of 100. So a percent is just a way to relate it to parts out of 100. Dealing with dollars, that's kind of nice because cents are all parts out of 100. Sometimes that's helpful. But in general, the setup, we're talking about, we know 2 or 3 out of these numbers, and we're always looking for the one part. What is the percentage, or what is the percentage, or what number would be a certain percentage, or what was the bigger number that we started with anyway? So we kind of have 3 basic translation shapes, you might say. So, time out. Let's back up and say, let's talk about creating a percent. All right, I'm going to do that. So, first of all, if we have a decimal value, we want to be able to convert it to the corresponding percent value. And so if I've got a number like 0.35, all right, if we read this as sort of the fraction equivalent of that decimal notation system, that's 35 100ths, right? Tenths, hundredths. So that's 0.35 is 35 hundredths, 35 cents, right? Well, as parts of 100, the percent value really is just the numerator value there. So that's equivalent to 35 parts of 100, or 35%. And notice that word cent, percent, right? Century, centigram, it's that like metric prefix for hundreds. Notice how we get from here to here. Move that decimal point over 2 places. And we can convert a decimal value into a percent value. 1.15, well, moving it over 2 places, I get 115%. You know, once I added the tip, I'm paying 115% of the original price. That might not be an unusual, situation, right? So, how much is your total bill? It was 115% of the amount we paid. We'll get there in the specifics. But again, moving it over 2 places. How about here, 0.034, well, technically 34 thousandths, but still as parts of 100, moving it over 2 places, I'm still going to have a number with a decimal in it, but that makes it 3.4%, right? A decimal part of a percent, 3.4%. So 2 places right get you moving from a decimal value to a percent. We want to be able to go back the other direction also, right? So if I have, get myself a little room over here. If I have a percent value and I want to translate it back into the corresponding decimal value, which we'll need to do in problems, we don't usually work with the percent in our equations. We turn it into the corresponding decimal. So going back, hopefully it just kind of makes sense to you, because trying to memorize left or right as a process rather than just understanding it. It might mix you up, but we're going 2 places left from where that decimal is. So this would be 0.55, 55/100ths. All right. 250%. Anytime you get a number over 100%, you're talking about more than one whole thing. All right. 250%, that's going to be 2 point something. So again, 2 places, move it over, and that's going to be a 2.5, and I'll just include the 0 because it was there to begin with. And these are the ones you kind of have to watch out for. 1.5%, because it's related to that last one I did in the other direction. I still have to move it over 2 places, and that means I need an extra 0 placeholder, right? I had to put in that extra 0 to move over 2 places. So 1.5%, or 1.5 100ths, right? Had to move it over and put in an extra 0 there. So 2 places, left or right, depending on which direction you're going. It's always move that decimal 2 places. All right. We'll run into rounding problems. Round to 2 decimal places, or round to the nearest whole percent. Let's think of that one. We'll do both here. Or really, I've kind of almost written this 2 ways to say the same thing. What if I have this decimal value, right? To round to 2 places, or round to the 100th place would be the second place. Remember our rounding rules is kind of just reviewing. 2 places means I want to stop here. That means this one is the testing number. Does it tell me to go up because it's closer to the next higher 10th, or go down? So of course 9 real close to the next level. I'm going to round up and say this is closer to 0.17. Okay, so just rounding your decimals. And I might say then that's 17%. So rounding to 2 places. Now, sometimes you'll be told to round to the nearest percent. And you really want to deal with that kind of question or requirement when you're still in decimal form. Round to the nearest percent, just like I did here. If I have 1.3649, who knows what's going on. If I'm going to round to the nearest percent, I really am going to round to the second place, decimal place, right? Second decimal place is the last, well, if we're rounding to the nearest whole percent, then we don't want decimal parts of our percent. If I just wanted to turn this into a percent, I'd move it over 2 places, and I'd get 136 and 49/100ths of a percent. All right. Well, I guess I could still do it. Just have to remember, maybe that's the point I'm trying to make here, is round to the nearest whole percent. Don't round your decimal value to a whole number. You've got to round your percent to a whole number. Right? Maybe turn it into the percent. Maybe I did say it backwards. Turn it into a percent. Now I can see I'm going to round it to 136. I hope that I didn't make that confusing, but just be careful if you're rounding it to the nearest percent that you don't try to round your original decimal to, say, a whole number. You've got to wait and turn it into the percent and round the percent value. But just reviewing the rounding rules a little bit. Okay. All right, kind of 3 types. Basically based on there's 3 different numbers, primarily in these equation shapes, and any one of those 3 could be the missing value. Here we go. I wrote one number is 45% of 80. This really utilizes those words, the symbols, translations that we've tried to talk about already. What number? There's our unknown. Is, this thing is whatever's going to happen afterwards. That's our equal sign. 45%, oh, we want to take 45% of 80. Okay. Change percent to decimal. You never put the percent value itself directly into the equation. You'll get a number that's 100 times off. So 2 places, right? I'll be careful putting the there. So 45%, this is the same as 0.45. Of is multiply. There's your equation. This one kind of nice shape, ready to go to work, right? Got your calculator, 0.45 times. And 36. 36 is the number, that's 45% of 80. Not quite half, right? 50 would be half. Good, keep going. This is the same situation. I just kind of reversed the way I constructed the sentence. 55% of 60 is what? 15% of my bill is 20%. I'm a big tipper. Anyway, so is what? Again, this one can kind of have that nice shape. All the work's going to be over here ready for us. 55%. Turn it to decimal. Times 60. 0.55 times 60. 32. A little more than half, huh? So there is sort of that first type where you know the original amount that we're starting with. We're looking for a percent of it. And what is that number that is that percent? Well, half another dollar sign. A second type. 7.5% of what is 195? Think about this, what this is saying. The 195 is the percent number. It is the amount. What was the bigger number, right? 7.5. So we started with a bigger number and took a small part of it. What was the original number that we took the percentage of? So we're looking for the starting value. So there's our variable. That'll be our equal sign again over there. Still, we have to convert the percentage into the decimal value to make it work properly in our equation. So 2 places over, here's one of those where I had to put in that extra 0, right? Placeholder. This number times the unknown resulted in 1.95. Some small fraction, right? Some small decimal part of that original resulted in that. Okay, so I got a little work to do to solve this, right? This is really multiplying my very small decimal, multiplying times the variable, and equals that. So we want to undo this multiplication. Just like if I had 3x equals 6, divide by the 3. Right? So I'm going to take both sides. And if we didn't get to use our calculators, this would be really annoying. You have to work on long division or something like that. So here they go away. And now I'll figure out what that is. Be careful with your decimal points and so on. 1.95 divided by 0.075. I'd like to look, make sure I got those in there right. And I got a 26. All right, very small, less than 10%, right? Less than a tenth, less than 2.6. Yeah, I'm down to 1.95. So the original value, I could turn it around and just say, did I get the right thing? If I do 0.075 times 26, did I get the 195? Yes, should do that. This was, if you've seen that in a word problem with a dollar sign, I should probably remember to put dollars on that. That's where I started. Again, the same situation as the previous example, but I kind of wrote the sentence in reverse order. This number is the result of 8.5% of some starting value. What was that starting value? Translating, what I'm trying to get at here, right? 3.06 is, convert the decimal, move it over to, and there's what we're looking for. Again, like that last one, to get the x value alone, we're going to divide by this decimal we put in there. See what we come up with. I got a 36. Does that make sense? Oh yeah, sure. Less than a tenth. This is less than a tenth of the original. Yeah. I'd like to do the, step back and do sort of mental estimating. Did this answer make sense for the numbers I started with? Okay, this number, small number, 8.5%. If you can kind of roughly go back and forth between, okay, 10%, that's 1/10, or recognize, 45%, that's a little less than half, 50%. You can look at your values and say, oh, am I in the right ballpark, or did I do something really completely backwards or wrong? But yeah, this is a little less than a tenth of 36. A tenth would be 3.6, right? And so this is less than a tenth, just less than a tenth. So yeah, I did okay. Use your mental math to do some estimating from time to time to keep you, help reinforce what you think you did. All right, third type. We found the actual number that was some percentage of starting value. We found the starting value that we took the percentage of. The third type is, if we've got these numbers, what percentage is this one of that one? What's the percent value? Okay. 110 is what percent of 88? We're looking for the percentage value. All right. Kind of a two-step here. We're going to find a decimal answer when we solve our equation, and then have to convert that decimal to percent notation. So these first two versions, I had to take the percent and move the decimal to turn it, move the point to turn it into a decimal value. Here we'll go the other way around. Otherwise, the translation is pretty much the same. 110 is what percent, and I usually just throw in a P here, just remind myself. This one's going to be a percent answer and helps me at the end to remember to change it. 88. So just to begin with, I like noticing, oh, this is bigger than the one we started with. I would expect a percent value over 100, more than 100%, larger, just by chance, this example. So solve for this variable. I'm going to divide both sides by 88. And calculator. And 1.25 is the decimal equivalent, or percent. Move it over. 125%. So three numbers generally in these equation shapes right now. You know, a starting value, a percentage of, and then the resulting value. And any one of those three could be missing. Could be what we're looking for. Again, the same type, and I just like showing how the sentence could be sort of constructed in opposite order. You still get the same pieces and do the same result, you know, type of calculation eventually. What percent? Oh, there's our unknown. So what percent of 72 is 126? I don't know why both these examples ended up with larger. So again, we're going to end up with a percentage over 100 again. Dividing both sides to get my variable happens to be p alone. And closer to 1.5 or something like that, huh? 126 divided by 72, 1.75, no. There's the decimal, that's 1.75, 1 75/100ths of 72. That's a percentage. Over 100%. There, that's all. But those are the basics, the first few mom questions. I believe are just like these three types here. You know, translate it to create your equation and then look to see what solving steps you need to do. Of course, then you get into more context, the word problem, and some variations that are a little more complicated. That's why I like the TAs. See how much of it we can actually present today and then spend more time with it tomorrow too. Let's say your bill, your restaurant bill is $81.50. Nice dinner for two someplace. Yeah. How much is an 18% tip? How much is an 18% tip? Now, if you can take this word problem, two sentences there, and sort of restate it in terms of one of those three types we just talked about, or that I talked about and presented, and then you can translate it to the equation shape. So I'm looking for, does it make sense? What is 18% of 8150? Right, that's what we're doing. We're trying to find 18% of, and I'll write that out. I boiled that original problem down to that percentage equation statement there. And I'm looking for what is 18% of 8150. If I convert it to decimal, somehow as soon as you jump into a word problem, it's the kind of thing we just might forget. Oh, I always got to turn that percent into a decimal if I'm going to plug that into an equation. How much tip should I leave if I have an 18% tipper here? So 0.18 times 8150 and $14.67. I think I'd be a bigger tipper, just round to 15 bucks. You know what they might do in the real world, but we're figuring out how to make it add nicely to the original bill. That's all side stuff you might really do in reality. Oh, what's the real close, nice round number to round my bill up to? But there's that value, 18%. If you were really trying to just get in the ballpark, what would 18% be? There you come up with, I know I want $14.67. You add to the staff's income there. All right, just gonna keep going like this, do another one. All right, what tip is 15% of $24? Just kind of tried to phrase it a little bit differently, but it's the same kind of problem. What amount, what number, what tip? All right, that's what we're looking for. And that one, I guess I kind of wrote it as more that simple statement to begin with. I didn't have to think to rearrange it too much. Right? But there it is. What's 0.15 times 24? $360. Watch out for context and word problems. Always problem like this one is ask you to express your answer in a complete sentence. Make sure you include units. So here, the tip amount would be $3.60. Problem like this might say, what's the final bill? Or what are you going to pay in total? Hopefully it makes sense. So I'm going to pay 24 plus the 360. You're going to just be careful. Read problem carefully. Make sure you're coming up with the final value that they're asking for. All right. More. Seven grams of fiber is 28% of the daily recommended value. Can I write that DRV? What is the daily recommended value? Okay. And here you can only kind of like compress the two sentences. I wrote it as two sentences, right? 7 grams of fiber is 28% of the daily recommended value. I'm looking for the daily recommended value for, yeah. Seven is 28% of what? And what that boils down to, right? The 7 grams is the 28%. 7 is 28% of some other value. Convert to decimal. Divide. You get X alone. How much fiber? $25 grams. 25 grams of fiber. Daily recommended. However you get that. Keeps you feeling good. And similarly, another kind of similar context, huh? If 8% of the daily recommended value of sodium is 190 milligrams, what is the daily recommended value? Kind of try to mix that one up, right? Let's see. So can you kind of unwrap it in your head, write that one simple sentence? 190 is 8% of what I'm looking for. If you can take your word problem and boil it down to that simple phrase that just includes those three quantities, I'd like to think then you can write the equation, and in general, they're not real complicated looking equations at this point. There's not a lot of parentheses and stuff like that. Right? 8%, how do I write that? Two places. I always do the zero in front thing. Right, 8%. Yeah, maybe just, you know, oh, if I've got a single digit percent, there's always a 0.08. And divide to get x alone. See what I get. (2,375 milligrams of sodium). That was from probably a text problem, this example, that I copied to my notes some time ago. So it's likely to be a real value. Maybe values for men and women are different, but 2,375 over the course of my lifetime, anyway, people have just more and more taken to looking at those daily values, those values on their bottles. You know, how much sugar is in here? How much sodium is in here? How much fat? You know, am I getting any potassium? I look for things like that. But kind of interesting. Sodium is, unfortunately, I guess it's one of those things that we all hear about. It's there's too much in all the processed foods that we buy. So, nice one to keep an eye out for. All right. Yeah, doing okay here. Uh-oh. Where's my notes page, students? And out of 230 calories, 60 calories are fat. What percent of the calories is fat? It's just like I was talking about. Oh, I'm looking at this product and a single serving is blah, blah, blah calories, and they'll tell you the number of calories. They also usually tell you a percent value too. That's a nice thing about, you know, how we use percents, right? We don't want a little bit of fat, might be okay. If I find that this is a huge amount of fat in this product, maybe I go elsewhere or something. Out of 230 calories, 60 are fat. What percent? So can you rearrange and write a sentence? What are we looking for here? We're looking for, well, I would call the p variable here for percent. How about 60 is what percent of 230? I kind of rearranged to make it look a little simpler to translate. All right. 60 is what percent times 230? Going to divide by the 230. And you can see, oh, if that was 240, that'd be 1/4. So this is going to be a little more than 1/4, which we maybe know is 25%, right? Stick that in your calculator. 60 divided by 230. 0.2608, a bunch of others. All right. The reason I have this one in my notes, it says round to the nearest whole percent. Well, that's a decimal value right now. It's not yet a percent. It's kind of almost mixed up at the beginning there, but I'm going to convert it to a percent with all those decimal places, and then I'll round it. All right, so that's moving over 2 places, right? 26.08%. And if I'm rounding, that's approximately going to drop, right? I'm rounding to the 6, whole number, rounding to a whole percent. So I just look at the 0, and it means I'm going to drop it and say approximately 26%. All right, 26% in fat. In that product, whatever it was. Well, you're doing well. Our last concepts in this section, and maybe if you're okay with it, we might just stop here, and we've done all the, I'd say the basics, and then the next step is what we call percent increase or percent decrease. If the price changed from this value to this value, what was the percent decrease? And there's usually basically 2 steps: finding the amount of change and then doing one of our basics here. But it might just be easier, rather than start that and run out of time today, we'll cover those next step kinds of problems tomorrow. Okay? All right, so you probably are able to get started and get at least halfway through the long questions now, if you wanted to try that. We do have a couple of minutes. I noticed most of you have gotten through last week's homework due tonight, right? Any questions, issues you're having you want to throw out, difficulties on the homework that's due today? And if you don't, I'll just say it over and over. If you're not real comfortable in like bringing up a question here, that's fine. But send me an email, send me a forum message. Ask me. You don't have to do it in the forum, right? There's that message feature, which is just like an email within Mom. And you can ask me your question just to me directly, and I'll write you some nice notes and give you some hints. And if you're really lost, I'll work it out. I'll try another one. Okay, but ask. I'll do what I can. If you ask me, let me know you'd like some help. There is also options out there. There are online tutors, regular scheduled periods during the day. Folks that you might have gone to the RCC Tutoring Center for, and they're sitting around the tables waiting to help you. They're sitting there online, waiting to do this kind of Zoom tutoring one-on-one with you. If you wanted to look for that, I think there's links. I put the links in my syllabus. I'm pretty sure I did that for the tutoring center access, or if you went to my Road, the Road website. Like Tutoring Center or something, you could find that. But there's folks out there, there's help out there. Okay. All right, guys, ladies and gentlemen, I'm sorry. I try to be careful when I'm writing that I don't use that generic. I think of guys as generic, and really you're supposed to try to avoid that. It makes sense. But anyway, you guys take care, and there I did it again. You folks take care, and I'll see you tomorrow. All right. All right, bye.